This is Lesson 5-1, Perimeter and Area. So we're starting Chapter 5 off, finding perimeter and areas of rectangles and triangles. The thing is, when you're doing these, you're going to end up setting up equations and solving for a missing part, just like we did at the end of Chapter 4. So let's start off with perimeter. And perimeter is the distance around a shape. And we're going to talk about rectangles first. So perimeter, the distance around a shape. If you were a farmer and you had a field, you would need to know the perimeter of that field if you needed to know how much fencing to buy to enclose that field. So the perimeter is the distance around a shape. One thing about a rectangle, the opposite sides are the same. So in example 1, it says the length is 13 meters, so you know if it's 13 on the bottom, then it's also 13 on the opposite side. And the width, it says that it's 8, so that means that it's the same over here on the left. That's why the formula for perimeter of a rectangle is 2 lengths plus 2 widths. Alright, so when you're doing a problem like this, it's pretty straightforward. They've given you the length and the width. You're supposed to find the perimeter. You are simply going to plug in the values. So for L, we're going to plug in 13. And for W, we're going to plug in 8. And that's all you're going to do. You're really just going to solve and do order of operations, which would say multiply first. So 2 times 13 is 26. And 2 times 8 is 16. And then finally you're going to add those two, which would make it 42. For perimeter, you just simply list the label of the units that are on the lengths of the sides. Because it is just a length, you would say that it's 42 meters. Perimeter is just a length. It's not a square unit or anything like that. It's just the same unit that's there. Question? Alright, example 2. In this rectangle, it looks like the length is 7.5 feet and the height is 5 feet. So again, on this problem, just like the first one, I formula, which perimeter equals 2 lengths plus 2 widths. Does somebody want to try this one? Tora, what would we do?
We would do 7.5 times 2.
Okay, this time I'm going to use parentheses for times because of the decimal. So 2 times 7.5 plus
2 times 5.
Plus 2 times 5. Okay, so by order of operations, what's 2 times 7.5?
15.
15.
Plus 10.
Plus 10, which would be
25.
25. And how would we label that, Tora?
25 feet.
25 feet. Okay, questions about that? So that's just a plain old straight up perimeter problem involving rectangles. Any questions? Okay, so let's go down now to triangles. The thing with a triangle is there is no fancy formula. I do have some vocabulary on this first triangle, so just so you can kind of see, this little box implies it's a right triangle because that's a right angle, and the two sides that come together to make the right angle are known as legs. That's why those are written there. The side opposite the right angle is called the hypotenuse. So that's just some vocabulary words that you need to know in case they give you a problem, and give it to you as a word problem. So when we are doing the perimeter of a triangle, the perimeter equals, it just says add up all the sides. So all you will do on this is you would put 10 plus 15 plus 6. And then I'm going to go ahead and just add 10 and 15 is 25 plus 6. And I would put 31 meters. And that would be the perimeter of the triangle. So those are the basic problems that hopefully you've seen before. Let's go to the next one where it's not quite as basic and there's just a little more to it. This one, example 2 on the triangles, we already know the perimeter. The perimeter is 33 yards. And we also know that this side is 8 yards. This side is 11 yards, but this one is x. We don't know it, and that's what we have to solve for. So we're going to set up an equation for this one. Perimeter would actually equal 8 plus 11 plus x. But I know what the perimeter is, so I'm going to plug in 33 in place of p. And on the right, I'm going to go ahead and add 8 plus 11 and get 19 plus x. Now, we just spent a whole chapter solving equations of all different kinds. This one would be considered a one step. If I want to get x alone, I'm going to subtract 19. And 14 equals x. So for my final answer, I'm going to say that x side is really 14 yards. Questions about that? So this kind of thing where you're setting up the equation, that's what we're going for. Okay? On the ones where maybe they've got the perimeter area, that's really what you're going to be doing. Any questions? All right. Let's see what else we're doing here. Now we're going to do one, and maybe somebody can help me with this one, where we have the perimeter of that rectangle. We also have that, and it's kind of hard to read, but this width looks like 13, and it looks like the length is x. So we're going to take this equation, P equals 2L plus 2W, and plug in the information that we have. Does anybody want to do this one? Okay, Josh, what would I plug in for P?
68.
So I'm going to go 68 equals, do I have anything to plug in for L? No, other than what? X. So 68 equals 2x plus, what about for W?
2 times 13.
2 times 13. So 68 equals 2x plus 2 times 13. What would I do next, Josh?
Take 2 times 13.
Which is?
26.
Okay, so the rest of the equation I'm going to bring down. 68 equals 2x plus, he said 26. This should look really familiar. This is our two-step equation. So what do we do next, Josh?
Subtract 26 from 26 in spot and 68.
Subtract 26 from each side. What do I get?
42.
42 equals 2x.
You're going to divide 2 from each side.
Yeah.
Increase on your x from each side.
Mm-hmm.
And you're going to get 21
And how? 1
meters.
meters. Perfect. Any questions about that? Yes, question? All right, so now we're going to move on to area, and area is the amount of surface that is covered by a shape. So we're going to start with the rectangle. Area formula is pretty basic. You should probably already know it. Area equals length times width. So in this rectangle, my length is 12 feet and my width is 5 feet. So basically all I'm going to do here is plug in 12 for L, 5 for W, and my area is 60. Now I want you to realize for the label, we took 12 feet times 5 feet. In other words, we took feet times feet, which makes it feet squared. So the area of that rectangle is 60 feet squared, or some people like to write it like this, 60 and then SQ feet, square feet. Here's the one way you cannot write it. Don't get confused. I've had kids do this before. They go 60 And then they put the squared right there and put feet. They get confused and say, oh, it's 60 squared feet. No, that is bad. Do not do that. That squared cannot be on the number. That would mean 60 times 60, and that's not the answer. It's just 60 square feet. So pick one of these two ways to label when you do area. One of those two. Now, we're talking about triangles, so we need to talk about them a little bit more than just what is right here. This one that is pictured is a right triangle, and the two legs that come together to make the right angle are called the base and height. And that's really great if you need to find the area and it's a right triangle. It's pretty easy. Use those two legs, base and height. But I do need to show you an acute triangle. An acute triangle, something like this, the height is not a side. It would be, if this were the base, the height would be a perpendicular amount that would come inside here, and you can tell about that right angle that's a perpendicular. This would be the height. It would be a dashed line inside, and the side that it's drawn to would be the base. And then I also need to show you an obtuse triangle. That even looks stranger. If this were my obtuse triangle and I had to find the area, I would need the base and height. This would be the base. The height is not even inside of the triangle. You have to do draw in what are called auxiliary lines. That means imaginary. And drop this perpendicular from right here. This would be the height, and it would not even be inside the triangle. So you have three different things you could be concerned with. If it's a right triangle, it's actually the sides, acute, one of the sides and the height inside of it, and then obtuse, one of the sides and a height outside of it. Okay, back to our area. Since a triangle is half of a rectangle, the formula is 1/2 base times height. So when I'm looking at this, and I've got the same dimensions as the last example, I'm going to do 1/2, oops, I left my highlighter on, 1/2, and I would put 12 times 5. And I could either do 12 times 5 and divide it by 2, or I can do half of 12, which is 6 times 5, and then I would get 30 feet squared. Questions about that? All right, let's do a couple where we have the area and we got to find measurements that are there. That first one, well, I think I already showed you the answer. Let me see if I can fix this a little bit. How about that? I'm sure you already saw it. Anyway, on this one, I know that the area is 48 meters squared, the length is 8, and we don't know the width. So I'm going to start off by writing the formula. A equals L times W. I know for A, I'm going to put in 48. For length, I'm going to put in 8, and W is going to stay W. This is a one-step equation where I divide by 8. So my W equals 6 meters. Okay, we've got one more. Triangle. You want to do it? Okay, what's the formula for area of a triangle? One-half base times height. What can I plug in for A? 120 times 1/2. What can I plug in for B? 60. And what can I plug in for H? X. Okay, so my tree, what is 1/2 of 60? So 120 equals 30x, and what's my last step? Divide by 30. When you have a problem like this, you can cancel out those zeros. And what's 12 divided by 3? So it would be 4, and what's my label? feet. 4 feet.